In this lesson, you will learn about similar figures and how to write proofs of them. We first need to talk about some properties of similar figures. Their corresponding angles will be congruent, meaning equal in measure, and their corresponding sides will be proportional. So here in this example, we have triangle ABC that is similar to triangle XYZ. So first notice the notation for similarity. We have our congruent angles, meaning the corresponding angles are equal in measure. And we have the sides, so this AB corresponds to XY. That ratio equals the ratio of the other corresponding sides. That means it is proportional. If those ratios are equal, it is proportional. The triangle similarity theorems that we will use to prove these figures are similar are angle, angle, side, angle, side, and side, side, side. Also, we will use the triangle proportionality theorem in a later lesson, but it's good to know that it does help with our similar figures in order to solve. You will need to recall on some prior learning. There are several definitions and theorems that you should already know from previous classes, but the most often ones we will use are alternate interior angles, corresponding angles, reflexive property, and vertical angles. Of course, you could recall on any of these properties, but those are the most common that we use for our proofs for similar figures. So let's look at our first example. Given that angle G is congruent, angle G is congruent to angle K, and angle I is congruent to angle L, we need to prove that these triangles are similar. We always start with our given statements. So our first statement was given. We actually have two pieces of given information. And that is enough to prove these triangles are similar. One of our theorems is angle, angle. We have two pairs of corresponding angles, so that has proven these triangles are similar. 1, 2, angle, angle. So two pairs of corresponding angles. Let's look now at example number 2. We have some given information, so we see those ratios are set equal to each other, so that means they're proportional. We are also given that angle N is congruent to angle Q. So let's start again with our given information. So notice where our sides are. We have MN that corresponds to PQ. Then we have the angle that corresponds, and then the side, NO to QR. So if you read those in order, side, angle, side corresponds to the side, angle, side, and the other triangle. That gives you the proof or reasoning for these similar figures. Side, angle, side. The sides are proportional and the angle is congruent, but it does matter that those go in order. Side, angle, side. Example number 3. So given, we see these sides setting equal to each other in our ratio, so meaning that they are proportional. So that is our given information. So ST corresponds to WV, and TU corresponds to VX, and US corresponds to XW. So that shows us by side, side, side that these triangles are congruent. We actually don't have to have any angles. It is enough to just prove by side, side, side. We would need all three sides, though, to show that similar figures. You cannot just have the two pairs of sides. It has to be all three pairs of sides to prove it by side, side, side. That's why there's three S's, because we need all three. Example number 4. So again, starting with our given information. That notation means parallel. So parallel lines GK and HJ, that's our given information. So anytime you're given some parallel lines or information about parallel lines, that's when you'll need to recall on your prior learning. We now see we have corresponding angles, so we need to look for some of those corresponding angles. To recall corresponding angles, we can say that I, H, J, so this angle here, I, H, J, that angle corresponds to angle G, this angle here. Because those are corresponding angles, that gives us one pair of angles that are congruent. And we can say that because we have these parallel lines. Those are corresponding angles. Well, now we can also see that angle I is congruent to angle I. That is always going to be true. An angle is going to be congruent to itself. So this angle is going to be congruent to itself, and that is important because we see that the GIK, the larger triangle, is what we're trying to prove to the smaller triangle, HIJ. So that is a shared angle in both triangles. That is called the reflexive property when an angle is congruent to itself. And anything is congruent to itself would be the reflexive property. So that is enough to prove the similarity because we have angle, angle. That is our reasoning to say that these triangles are similar. Example number 5. So again, we see some information about parallel lines. So that's when you're going to recall on your previous learning. We see a given statement here that we need to give our reasoning. So QMN, Q to M to N. So we're looking here at this angle, QMN. So this angle, OPN, so O to PN. So we're comparing these angles to one another and determining what they are in relationship, knowing that we have these parallel lines. Well, that pair of angles, which are congruent, are alternate interior angles. We're also needing to look for some vertical angles. So here we have a pair of vertical angles, and we will need to call them with the 3-letter naming. You cannot just say angle N. There's actually 1, 2, 3, 4 angle N. So we need to specifically talk about the angles in the triangles. So MNQ talks about this angle here, and ONP is this angle here. And those are vertical angles which are congruent with one another. So now that we have two pairs of corresponding angles that are congruent, we have proved it by angle, angle. So always keep in mind with similar figures that your corresponding angles will be congruent and your corresponding sides will be proportional. Or you can prove these similar figures by angle, angle, side, angle, side, or side, side, side.